All right, so the only thing that the recording missed is that it has to be a straight line and go through the origin. Straight line through the origin. Straight line not through the origin would make it non-proportional. All right, here are the few examples. There are 3 or 4 today. Let me see. Yes, 4 examples today. The first one, a rabbit challenges a tortoise to a race. The table shows the distance that the tortoise moved after 0, 1, 2, and 3 distances. So we're trying to figure out if it is proportional. We're gonna graph these points. Remember, these are listed X, time is on our X axis, and distance is on our Y axis. So this is the point 0, 0. Here is the point 0, 0. This is the point 1, 6. So between 0 and 2 is 1. Between 4 and 8 is 6. So here's the point 1, 6. Then we have the point 2, 12. I don't have any Band-Aids. You can go wash your hand and it will be okay. You can go wash your hand real quick and I'm sure it will be just fine. And then 3, 18. Probably. All right. So we have to describe the relationship after we've plotted these. The line is straight and it passes through the origin, right? Straight line passes through the origin. So it is proportional. That's what we've been working on. So look here. We're going to graph this relationship. Snacks. 1 piece has 5 calories. So here's 1 piece, calories per piece. Well, this is kind of silly that they didn't go by 5s, right? So between 4 and 6 would make it 5. At 2 pieces, it has 10 calories. So we're going to go up here to 10. That's between 8 and 12. And 3 pieces have 15 calories. So that is between 14 and 16. Oops, right over here. So how many calories would 0 pieces have?
0.
0. So does this start at the origin? Yes. So this is still a straight line through the origin. All right, look at this next example. Ha. All right, we're gonna plot these points. 0, 0, we can do that, right? 1, 8. Here's 1, here's 8. This is 2, 8. Here's 2, here's 8. Here's 3, 15. 3, 15. Is this a straight line?
No.
No, it changes. So is this, so it's telling us it is not proportional because even though it starts at the origin, it is not a straight line. Not a straight line. Okay? So now they're going to give us one to check. This one, we're starting at 0, 10. After we plot this point, you should realize since it doesn't start at the origin, it is not proportional.
That's the only reason it's not proportional.
Yep, we're gonna see that it makes a straight line, I think. Let's look. 112, so right here, 214, and 316. So this is a straight line. This is a straight line, but does not start at the origin. So we call this non-proportional. Okay, so far, examples 1 and 2, pretty straightforward, yes?
Yeah.
Yes. If it's proportional, it starts at the origin and makes a straight line. All right, when a proportional relationship is graphed, you can determine the constant of proportionality. So here we are back to the constant of proportionality. What's another name for the constant of proportionality? What did we call it? This is page 34. Yesterday we called it a
Holy, is someone like?
unit rate.
I feel like he's screaming. Are you screaming?
I'm mic'd.
Oh. Makes sense.
So this is gonna help us find our unit rate or our constant of proportionality. Here it is. The constant of proportionality is the ratio of y divided by x. So here, for any point on the line, except 0, 0. So write each ordered pair and write the ratio y over x when x equals 1 for each. So they wrote this point, this is the point 210. So they said 10 divided by 2 is equal to 5 over 1. Here, this point is 315, so they wrote y divided by x, or 15 divided by 3 is the same as 5 over 1. Same thing for this point. This is the point 420, so they wrote the y value divided by the x value to get the unit rate, or in this case, the constant of proportionality. Okay? So now, for example 3, we're going to practice finding the constant of proportionality from the graphs. In this example, they're doing it for us. They're picking these points. This is the point. They're telling us it is 531. This is the point 531. They're taking y divided by x and getting that 6.2. This is the point 10 and 62. You can see here, it's hard to figure out what numbers those are. So I'm not sure why they made this not as obvious as it should have been. And then here, this was the point. The x value is 15. The y is 93. That's why they took y divided by x to get the constant of proportionality. So because the constant of proportionality is 6.2, this means that the runner moves at a rate of 6.2 meters per second. Now, we know that because that's our unit rate, right? Constant of proportionality and unit rate are the same thing. When we have something that starts at 0, it's also our slope. But you don't have to worry about that this year so much. Maybe a little bit at the end of the year, we'll look at that. All right, Brianna's saving her money. What's the constant of proportionality? See, it's necessary for them to give us these points. We have to use y divided by x, which in this case is 40 divided by 2. What's 40 divided by 2? 20. Let's make sure it's the same here. 80 divided by 4. That's also 20, right? So what's our constant of proportionality? 20. That constant of proportionality is $20 per weeks. Notice y divided by x is dollars divided by weeks. So here she saves $20 each week. All right. Another way we can find the constant of proportionality is by finding when x is equal to 1. So the point 1r tells you that the constant of proportionality or the unit rate is r. It's the y value, right? Because r divided by 1 is a unit rate. This is equal to y divided by x. That gives us our constant of proportionality. Remember, this is only if it goes through 0. That makes it proportional. A straight line going through the origin. All right, let's look at page 36. Here we're going to practice. So at the point 1, this is 1r. This is our constant proportionality. So the point 125 means that for one teacher, there are 25 students. The unit rate is 25 students for every one teacher. So that's what we're figuring out here. Here, the unit rate is the same as 1 and this. We're using this. When x equals 1, we can find our unit rate. So the unit rate is 5/10 here, which means, what does it mean? For every 50 cents per ounce. So it costs $1 for every 2 ounces.
No what?
If it's 50 cents per ounce, it costs $1 for every 2 ounces. Or $2 for every 4 ounces, so that would work too. All right, let's practice this. It is on page 39. Yep,
I already did it.
page 39. So you're going to plot these points. So is it proportional? And you're going to explain. So remember, in order for it to be proportional, it has to go through the origin and be a straight line. So try those. Yep, you can do it on the placket if it's easier. That's fine.
Are they the same?
The packet, where's the packet?
I already did last week, so that was what, they were really easy actually. Like, I feel like.
1, 4.
Wait, it's 1, 3.
This is 1, 4. So 1, 4 looks like numbers. 3. Number 3 and number. Number 3, number 7. Number 8. I don't see the temperature one, but I might have gleaned over it. So remember, your quiz was going to be on 1-1 through 1-4, so make sure you're getting in lots of practice. Monday, we're going to practice 1-4 some more. Tuesday, we're going to review. Wednesday, we're going to take the quiz.